Okay, now we're going to go through some more complicated mole equations. These ones we might be given the number of particles and we might need to get all the way back to mass. So we might be given this, we want to get back to this, or vice versa. Now you can't do that without converting through mole first. So we need two equations here. So this one over here is my first equation, N equals M over MR. And this equation over here is going to be N equals N over Na. All right, so they're the two equations on the two different sides there, but we use the mole to convert between the two. So let's have a look. Now we want to know how many molecules are present. So if we want to know how many molecules are present, we want to know the capital N. We've been given the mass. We've been given the mass. I'm going to do this in a different color to make it obvious. So the N is what we want to know. So that's the question mark. We've been given mass. We can figure out the MR. We can use those two things to figure out the mole. And then we can use the mole and Avogadro's number to figure out our capital N over here. So capital N is going to equal to N times Na. So what this looks like is we need to find our mole first. Mass from the question, 0.2008 divided by 60, which is the MR of CH3COOH. And we end up with this mole. So it's not good enough to leave it there because we don't want to know mole. We want to know the number of molecules that are present. So now we're going to do the number of molecules, which is capital N, is equal to mole times Avogadro's number, which is what? 6.02 times 10 to the power of 23. And we end up with 2.01 times 10 to the 21 molecules. We're going with 3 sig figs because the highest initial, why did I go 3 sig figs? Is because this one here has got 3 sig figs and that was in your question stem. So that one there is my lowest accuracy. So I'm going to go with 3 sig figs for this question.